Welcome everyone to another deep dive on our Explainer series. Today, we are entirely focused on decoding the Cambridge 9618 AS and A-level computer science exam. Now, if you're gearing up to sit for paper 2, well, you are in exactly the right place. We are literally opening up the examiner's playbook today. We're going to master a very specific, absolutely critical segment of the syllabus, the assembly language instruction set. Specifically, we're putting a massive spotlight on 5 instructions: INC, DEC, JMP, CMP, and CMI. I am so thrilled to walk you through this because, honestly, mastering these, it isn't just about memorizing some old-school code. It's about understanding exactly how the examiners think. It's about knowing what they are desperately looking to award you marks for. So, grab your notes, get comfortable, and let's get right into it. 15%. I really want you to let that number sink in for a second. Did you know that this specific assembly language instruction set accounts for approximately 15% of the total marks in paper 2? That is a massive chunk of your final grade sitting right here in these 5 simple commands. To put that into perspective, that 15% is often the exact difference between bumping up a whole letter grade or slipping down one. This isn't just a minor, obscure topic you can afford to skim over the night before the exam. No way! This is prime real estate on your exam paper. Grasping exactly how these instructions operate and, more importantly, how they interact with each other is often the defining factor between just an average grade and a truly outstanding top-tier performance. But, that brings us to a really massive roadblock, a question we have to ask. Why do students consistently lose easy marks on multi-step calculations involving these exact instructions? Year after year, the examiner reports tell the exact same story. Examiners see students who clearly know what the acronyms mean in isolation, but they completely fall apart when they have to string them together to solve a complex problem. The tension in that exam room is real, and the difference between the average student and the top-tier performer almost always comes down to how they handle the friction of these multi-step processes. When the pressure is on, logic often goes out the window. Well, today we are going to fix that completely. Okay, let's dive into this. Here is our high-yield game plan for the explainer today. Part 1, we're breaking down the core instructions. Part 2, we're going to uncover the method mark strategy. This is a real game changer. And Part 3, the top 3 examiner warnings directly from the source. We've got a lot of ground to cover, so let's not waste a single second. Starting right off with Section 1, we are looking at the absolute foundational tools you are given in this syllabus, the core instructions. So we have these 5 fundamental commands to master: INC, DEC, JMP, CMP, and CMI. Now these instructions, they are the building blocks. They dictate exactly how data is manipulated, how the flow of the program is controlled, and how logical comparisons are made within the system's architecture. On the screen, you'll see a column labeled Mnemonic Hack. I'm going to challenge you right now, come up with your own memory hack using the first letters of these key terms. Seriously, pause and think of one. Locking these 5 acronyms into your mind is step 1. But, as we are about to see, just knowing what the letters stand for absolutely won't get you the high marks. It's just the starting line. And here is exactly why. What you're looking at is a direct mandate from the Cambridge syllabus itself. It clearly states that mastery requires a connected, conceptual understanding transferable to unfamiliar contexts. Think about what that actually means. Cambridge is explicitly telling you that they are not just testing your memory. If you just memorize what INC or JMP does in a vacuum, you will literally fail the higher mark questions. They are looking for logical, structured reasoning. They want to see that you have analytical depth rather than just superficial, surface-level breadth. You have to be able to take these 5 instructions and apply them to a completely weird, unfamiliar scenario that you have never seen before in your textbook. And that leads us perfectly into the cognitive domains. These are the specific areas the assessment objectives target when they test this instruction set. The examiners are grading you across 3 distinct tiers: knowledge and understanding, application, and analysis. Knowledge and understanding is the baseline. It's simply knowing what the command does. Application is a step up. It's using the command in a basic loop or a simple conditional statement. But analysis, that is where the heavy lifting happens, my friends. That is where you have to trace the logic of a complex block of code, predict the final outcomes, and structure your reasoning flawlessly. That's where the A-stars live. So how do we conquer that analytical domain without getting overwhelmed? Let's move right into Section 2, the method mark strategy. This is where we shift our focus to the procedural side of the exam. Now, what's really interesting about this slide is the psychology behind it. The method mark strategy is the process of earning marks specifically for demonstrating the correct procedural and problem-solving process with clear working. What does this mean for you sitting in that exam hall? It means the examiners actively want to give you points. I'm serious. Even if your final calculation goes completely sideways, or you make some tiny, silly arithmetic error near the very end of a complex assembly code trace, if your method is clear, visible, and logically sound, you secure marks. You literally get paid for your process. To guarantee you capture those method marks every single time, your problem solving needs to use a strict deconstruct, solve, evaluate framework. It's a 4-step process. Step 1, identify the given information. Write it out. Step 2, break the problem into logical steps. Step 3, solve systematically. Step 4, check for reasonableness. For instance, if you are tracing a program that uses an INC command followed by a CMP command, you do not just jump to the final register value in your head. No way. You write down the register value after step 1, then update it for step 2, and so on. You have to show the examiner your brain working on the paper. Let's move to the next level and see how this builds. This 4-step framework expands into the ultimate standardized sequence for practical application, giving you 5 key actions. 1, identify the key elements. 2, apply the relevant principles. 3, execute the analysis with absolutely clear step-by-step working. 4, verify your results. 5, present your answer in the appropriate requested format. Whether you are designing algorithms, implementing solutions, or evaluating system performance, this is exactly the systematic processing that the academic benchmarks demand. Do this, make it a habit, and you will capture every single available procedural mark. All right, now that you have the tools and the strategy, let's look at the pitfalls. Section 3, the top 3 examiner warnings. We know what you should do. Now let's look at where thousands of students go wrong every single year. This is high-stakes insider information. We went digging through the principal examiner reports, and these are the top 3 mistakes that cost students easy marks. Number 1, forgetting to check overflow and edge cases. Seriously, when you are incrementing or decrementing with INC and DEC, what happens at the absolute limits of that data type? Do you get an overflow error? Number 2, forgetting to check boundary conditions. This is huge when using CMP and JMP to control loops. Ask yourself, does the loop stop at 9, 10, or 11? Off by 1 errors are a classic trap. And number 3, answers that are not specific to the given context. Take a mental note of these right now because avoiding these 3 specific traps puts you ahead of the pack instantly. Actually, I want to double down on that 3rd mistake because it triggers a massive red flag for examiners. Generic answers lose marks. Scenario-specific context secures top marks. The classic mistake is giving a rigid textbook definition of an instruction when the question asks how it functions within a specific scenario, like a smart home system or a robotics controller. You must always link every single point you make to the exact scenario provided in the question text. Do not just write what INC does generally. Write what INC is incrementing in this specific machine. Context is king. As you push into the higher order assessment objectives, you're going to be asked to evaluate algorithm quality and actually compare alternative approaches. When you are asked to make justified recommendations, you need to base them on these 4 key factors: time complexity, space complexity, edge cases, and the overall effect on performance. Sure, using a jump command might solve the problem, but does it create a less efficient time complexity compared to another method? Is it going to take up more space? This is the analytical depth the examiners are practically begging to reward. So the crucial point is captured beautifully in this quote from the syllabus, bringing our whole explainer full circle today. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. That really is the golden rule, guys. It's not about the acronyms. It's about the architecture of your thinking. If you use the systematic method mark strategy we discussed, and you absolutely avoid generic answers by tying everything back to the scenario, you are demonstrating exactly this level of mastery. So, here is your action plan. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Your homework right now is to take this exact framework and practice past paper questions, specifically targeting the INC, DEC, JMP, CMP, and CMI instructions. Get your hands dirty with those code traces, show you're working clearly, and we will see you in the next masterclass. I want to leave you with one final provocative question to carry into your next study session. Think about it. How will you apply the method mark strategy to your next multi-step calculation? The next time you face a massive wall of assembly code on an exam paper, are you going to panic and rush to the final answer, or are you going to deconstruct, solve, and evaluate step by step to guarantee every single one of those procedural points? The choice, and ultimately the grade, is entirely up to you. Thanks so much for learning with our explainer today, and keep building that connected conceptual understanding.